errors into a structured object. And if we'd made a syntax error in here, then this would blow up. But if this doesn't make a syntax error, if this doesn't blow up, then we have a structured representation. Now the difference between XML and Python, JSON, is that this turns into a Python dictionary with key value pairs. Okay, and so once we have this, this is a dictionary. And we can say info subname, and that's the exact syntax that we would use to get the dictionary, and that's going to extract this value out of there. And if we want to go in deeper, we can say info sub email, and that's what info sub email is right there, and then sub hide. So that's a dictionary within a dictionary. And so if we run this, Python 3 JSON 1.py, it digs in really fast. And so this is why people tend to like JSON, is because you read the JSON, which is actually a syntax derived from JavaScript, but it looks just like the syntax for Python. So it's moving that's moving an object, a JSON object that turns in directly into a Python dictionary with nested dictionaries. Now we're going to look at JSON 2. And so JSON 2, we're going to see a list, or an array in JSON terms, but it turns into a list in Python terms. So this is a list of dictionaries. In JavaScript, that would be an array of objects, but in Python, it's a list of dictionaries. So we'll just pretend that it's a list of dictionaries. Again, we load the string, parsing, looking for syntax errors. So let's just make a syntax error here and run Python JSON2.py, and you'll see where it blows up. It blows up at line 15, which is right here. It's like this load S blows up. Now you could put a try except around it to save it, but we're not going to do that. And it even complains. It says, look, we're expecting something here in line 11, and that's line 11 of the JSON, which starts at line 4. And so I'll put my little square brace back in so it's not syntactically broken. So let's run it again and make sure that she runs, and yes, she does. So this parses it and converts from the JSON syntax into a Python, in this case, list, because it's got square braces instead of curly braces. The previous example had square braces. And we can then take a len of it, and it's an array, it's a list, and we see that there are two things in there. And then we're going to iterate through, and this item is going to iterate through these dictionaries, that dictionary followed by that dictionary. So the first time it's item sub name, which is this value right here, and then item sub ID, which is this value. So you can dig right into this, but you're not using get, and you're not using the weird extra find or find all or anything. You just are going at these structures directly. And so you can quickly extract this stuff out, and we read through ID is name is Chuck. Oops, name is Chuck. There are no attributes, by the way. X is 2, and so we had to make X. So if you look at the XML, we had this concept of attributes on the outer tag. These things are also not named. We just have to know what we're looking for. So JSON represents simple structures, but it's much simpler to use. So I hope this has been useful to you, and talk to you in a bit about some more JSON. So the service-oriented approach is a way we approach solving a complex application problem where all the data really isn't present in one computer system. It's somehow spread out over the internet, connected via the internet or internal network. And so the idea is that some applications just can't contain everything. The perfect example is a travel website that can book you a flight, book you a car, buy tickets, book you a hotel, and do all these things. Well, that travel website is neither a hotel nor a rental car company nor an airline. But what it really does is it talks to all these services somewhere else on the web on your behalf, and it makes reservations for you. And so you have this convenient user interface that says, oh, here's your whole vacation. I'm going to figure all this stuff out. Now you say go, and it goes book, 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 and books on all these other systems. Now it requires a lot of infrastructure, a lot of coordination, and a lot of effort to make sure that your application can talk, and these other services that are out there in the internet have good contracts, and you know exactly how to send data to them and get data back from them. And so initially, when you're building a service-oriented architecture, often you have one application, and it's all internal. Often it's all one language, and then maybe you'll say, oh, wait a sec, we want to take part of what we do and put it in a second system, and then sort of come up with a set of rules between the systems, and then more and more and more. So now that we're solving our problem using a series of cooperating applications communicating across the network, we're going to talk a little bit more detail about the notion of what we call web services. And in this, we're going to take a different perspective. Instead of building our application and breaking it into pieces, we're going to have an application that's going to really consume an API from somebody else. So there is some other provider of this API that's not us. And so if you're going to talk to somebody's data, like Google or Amazon or Twitter, they're going to say, you have to use our API. So what's that? So an API is a contract that says, look, if you do this, and this, and this, and this, we're going to give you data this way. And they set the rules, they tell you what the URLs are, they'll tell you if it's XML or JSON, and this is called the Application Program Interface. And it's something you read and you understand. And so you go look at the documentation. This is the documentation for the Google Maps API. So it turns out that Google knows a lot about maps. It knows a lot of data, it knows how to search maps, and it actually provides some of those features to you that your application can take advantage of. I took advantage of this at one point by asking all the students in one section of one of my online courses where they were from. And I just let them type in where it was. And then I said, well, I don't know how to code any of that. So I used this API doing what's called geocoding to look all those places up and get precise latitudes and longitudes for the ones Google could figure out. And that saved me a lot of work. Now, these are expensive resources, but I could be patient and make use of these resources, which as long as you use them not too much, they can be free. We'll talk a little bit more about rate limiting and what's free and what's not in a bit. But you start by reading documentation. It says, do this, hit this URL, hit that URL. So if you read that documentation, you will find that there is a URL that you can hit. And they tell you where to go. And then you go to this URL, you add a question mark, and then you say address equals, and then Ann Arbor plus, and there's all these rules. These are called URL encoding rules when you have key values on URLs. The plus means space, and %2c means comma. So these are called URL encoded. But don't worry too much about that, because we're going to have a magic library like we always do in Python that takes care of this. And so if you were to hit this URL, you type it in the exact right way in your browser, you will get back a JSON document. It's an object that has key value pairs. The first value is this status, then it has these results, and it's a list. And you dive down, and eventually you can kind of find the latitude and longitude of the thing that you are looking for. And so the idea is, can we write a program that can read this? And so here's our little program that reads this. And a lot of this is sort of comfortable. You've already seen some of this. You import URL lib. We have to parse them JSON. We grab the URL. And then we're going to write a little while loop that's going to ask for a location. And we can type that location in. And we've got to concatenate with this URL the location equals. And there is a bit of code, a library that called parse URL encode, that takes the key and the value, so the address equals, and then whatever this text is that we read in from the user, that goes in here, and it does that URL encoding with the pluses and the %2c, and all that stuff is taken care of, and that is our URL that we're going to pass to URL open. So we print out that we're going to retrieve it, prints this out, and if you look at this, it's too long, it has all that fancy stuff on it, and then we read it. We open it with URL open, and then we read it and decode it. So these two things, hit this URL, decode it, and then we retrieved 1669 characters, because it's just in this case, because we've decoded it, data is a string now. That's read is bytes and data is a string. So we read that many characters, 1669 characters, and then we're going to take this data and we're going to parse it with JSON. And we might get bad data here. It might blow up, but it might work. And so in this case, it works. We have an error that basically says if we got a bad thing, we're going to blow up. But in this case, it doesn't blow up. And so now we're going to sort of dig through. And if you go back let me just go back. So the results sub-zero geometry. Let's show you how that works. So results is the first key. So this is a dictionary with a key of results, but then it has a list, and the 0 item, this list starts here and goes there, and I'm only going to show part of it, but there's many things here. So the 0 item is this. This is the sub-zero. And then geometry within that sub-zero item. So if we look at that, it is the outer dictionary, the first item of the list, sub-geometry. So that grabs one part. That grabs this part right here. And then we're going to go into location and lat. And those are just keys within keys, a dictionary within a dictionary. And so you see it says sublocation, sublat. And so that is literally going to pull out of that complex structure, that will pull the latitude out, and then in the next line, pull the longitude out. So we can pull the latitude and longitude out, and then we print it out. We can go into results sub-zero formatted address, and that goes into results 0 formatted address, and that pulls this little bit out. Now it takes a little while to write this stuff, and you have to put a lot of debug, and you don't necessarily figure out this complex bit here at the end, but you know, you print it, you don't get what you want, you say, oh wait a sec, that was an array, so I got to add a little sub-zero there to get the first one out of the array, but eventually you figure it out, and it's not all that difficult. It's the first few times you do it, like, what am I doing? But after a while you realize, oh, I'm just sort of tearing this apart and digging deeper and deeper into this data structure, which I just retrieved over the internet from Google, and I learned something good from that. So up next, we're going to talk about how sometimes these APIs protect themselves with keys or signatures, and why that happens and how to solve those problems. We are doing some code samples here. If you want to follow along, you can download the sample code all in a big zip file. I've got it. We are going to be working with the Google Maps API. In the old days, this Maps API was free and did 2,500 requests per day, but now they've made it so that parts of it are behind API keys, and you start having using OAuth and stuff. But they haven't put it all behind this one address service that we've been using. That continues to work. And the basic idea of an API is you go read the documentation, you find a URL, and this is going to Google servers, and you pass in the address. And we have to pass in the address using what's called URL encoding. So spaces are pluses, that's a comma, and then that's a space. And so we have to pass this in a certain way, but if we do it right, we hit this, we're going to get ourselves some JSON back, and that's really cool. And so deep inside here we get the real address, you know, a good address, we get a geometry, you know, we have the location, we got the latitude and longitude, and we can extract stuff out of here. And so we're talking, and this one here is still rate limited to 2,500, but it's one of the few parts of the Google Maps API that is not hidden behind an API key. In a later chapter, we'll show you how to actually talk with the API key in the geodata code. The geoload shows you how to use an API key if you want to jump ahead and take a look at that. But for now, we're just going to take a look at GeoJSON, which is going to retrieve one page and tear it apart. So let's take a look. So we're going to grab the URLlib stuff and import JSON. So now we're going to use JSON, but we're going to actually pull the data out of the internet. And so I just take that service URL for Google Maps API. I found that somewhere in the documentation. And then I'm going to have a loop that's going to run forever. I'm going to add the location. And then if I hit enter, that's what this is saying, get out of the loop. And then what I'm going to do is I'm going to concatenate the service URL, which is this, and this URLlib parse URL encode gives a dictionary of address equals. And this bit right here gives me the string that leads to putting this address equals, but encoding these spaces the right way. So if you type a space, that bit of code turns it into the plus. So that's important. And I've got the question mark sitting here at the end of that. Then what we're going to do is we're just going to do a URL open to get a handle. We're going to read the whole document, and because it's UTF-8 coming from the outside world and we want it turned into Unicode inside our application, we say .decode. We can ask how many characters we got, and we put our JSON load S. Now, up till now, we've been just doing load S's from internal strings, but this is now a string that came from the outside world, and we'll put a try except in, and we'll set JS to be none, and that'll be our little trigger. Now, we can look for, they give us, if we take a look at the output, they give us this OK, and that status can be a problem, and it can complain about things. So we have to check to see if we got a good status. So at this point, if you look at the outer bit of this, the outer bit that we get is a curly brace, so it's a dictionary. Then there is within that dictionary a key results, which is a list. But then the second thing in the outer dictionary is status. And so we can ask if if we got a false, if we got nothing, that we'll quit. If we don't have a status key in that the object or that dictionary, or it's not equal to OK, any number of those things, if this or this or this are all, either of those are true, we're going to quit. Failure to retrieve and print the data out. And when you're starting to read stuff off the net, you often have to put debugging in here like this, like, oh, something quit, I got to figure out, and so debugging it. Next thing we're going to do is called JSON dump S, which is the opposite of load S, which takes this array that include dictionary that includes arrays, and we're going to pretty print it with an indent of 4, and then we're going to print that out. And so if you look at my code, we'll see that the first thing we do once we parsed it is we print it back out so we can see it, and then we're going to dig into it. So let's go ahead and run this code. Python geojson.py. One of these days I will always type Python 3 and Arbor, Michigan. Okay, so it ran, and so you see that it retrieved this URL. This URL was constructed and it retrieved 1736 characters, and it's JSON pretty printed with an indent of 4, and this is that JSON dump S all the way down to here. So that's just JSON dump S, and then it starts extracting. So it's going to pull things out. Now when you write this code, it's really easy to look at this and say, oh great, it's easy. I tend to have to print this stuff out over and over and over as I kind of construct this expression. But if we look at it, the outer dictionary sub-results leads to this array. And if you go look at this array carefully, you find there is only one thing in it. And so that the results is an array. Sub-0 gets us this dictionary. I keep wanting to say object because that's what it's called. And that goes all the way down to here. So that's what we get there. And then within that, we now have an object, and we look for geometry within that object. Where is geometry? Right there. Geometry. Geometry goes from there to there. There's geometry in there. You got to get used to it. That's why it's nice to have this stuff indented. Geometry sub low. Oops, come back. And then we go to location within that. So location within geometry. And then within location we have lat and long. And so this is pulling out this 42 and 83. And then, so we print that out. Take a look. And that prints that out. Pulls that right out of the JSON. These are tricky to write, but after a while you win and you get it right and it's just fine. Okay? And so we do the same thing. Result sub-0 formatted address gets us this. And so that's how we print the location out. And so that's a real quick look at how we would do that with the JSON talking to the Google Maps API. Okay? Hope this helps. Now we're going to talk about API rate limiting and security. The key thing is that the Google API and the Google data is super valuable. And you could build a website that did nothing but sort of like asked the person for something and then showed them that place and make it be a map searcher. And you added so little value and Google did all the hard work. And so they protect these somewhat. Sometimes they'll say you can only do 50 of these a day or 500 a day or whatever. That's called rate limiting. And sometimes they say you've got to log in, you've got to create an account and get a key with us and then present your keys. So that means that your account only gets so many. And they keep track of who's using their service and how much they're using it. Google gives you even sort of a dashboard that tells you some of this stuff. It's kind of nice. And so the other thing is sometimes an API is free and then it becomes popular and they decide they're going to put a key on it or a rate limit on it. So you got to kind of play this game with them, and the rules kind of change as things progress. So that geocoding API that we're talking about has at one point in time 2,500 requests a day. You can get more requests if you get a key. Now, another API that we can talk about is the Twitter API. Now, Twitter API started out as a free public API, but then Twitter realized that people were making more money off of Twitter's data than Twitter was making off of Twitter's data. And so Twitter makes it so that you have to have an account. You can only request data from their API is if you use your account key to sign that. And so there's a whole series of getting and issuing keys and then using those keys. And I'll just give you a short summary of the kind of code that it takes to build those requests up that have to be signed. So you'll look through the Twitter documentation and it'll say, oh, this URL to get the tweets, etc., etc. And it says do a GET request to this URL and that URL, and maybe substitute a little bit of things here for the screen name you're looking for or how many tweets you want. And they tell you how to carefully construct these URLs. And so here's an example bit of code that talks to the Twitter. Now, for now, I'll ignore the security bit. That's all hidden in this TWURL. So it looks a lot like the last one. We're going to use JSON and URL lib. And we have found that this is the API name, blah, 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 list.json, getting a friend list for a particular person. And so that is the base URL that we're going to do. We're going to ask a person for a Twitter account. If we hit enter, we're going to break out. And TWURL augment, we're going to say, give me the first 5 friends of this particular screen name, the one we just read in from input. And this TWURL, you'll see in a second, it adds a bunch of stuff to prove that you are who you are. It's signing that URL. So you're sending a signed URL, which is nothing more than a whole bunch of crazy characters. We'll see that in a second. We retrieve it, and this is pretty straightforward. We can just, open the URL, read it, and decode it. Decode solves the UTF-8 thing, makes it all so that data is a real string and it's in Unicode internally. Now we can actually get the headers. Remember I told you earlier that URL open bypasses the headers, but it's stored them for later. And we can say, hey, give me back those headers. And that gives us back a dictionary of headers. And the headers, if you go all the way back, are a bunch of key value pairs. Key, value in the headers. And in Twitter, if you read the documentation, there's this x-rate limit remaining that tells you each time it returns to the API, response to the API call that you made, it says, look, you've got 12 left. You've got 11 left. You've got 10. So you can print that out. So this prints out how many you've got left. Then we parse the JSON data. We're going to print it so we can debug it. This dump to string and then printed. Indent equals 4. This is called pretty printing. And it's indenting things really nicely so that you can make more sense of it. Whereas when these things are when programs are talking to each other, they don't really make the output look particularly pretty. And then if we're going to go through, we have the outer thing of users, and we're going to print out the screen name and go grab for each user and users, we're going to print their screen name, we're going to grab their status text and print that out. And so this is what that data looks like. Kind of chopped a bit. So the thing we get is an outer layer, we get users, and then we get a list. And here's the first user. Now if you look at the actual data, it's much larger than this. Here's a second user, and then we have status text, and the screen name. Right? And so those are the bits that we're extracting from that. If you look, we're going to grab the screen name, we're going to grab the status text, and away you go. So you You can start with this, but you realize that once you're looking at this and you're printing this out with Pretty Printing, you can sort of work your way in, knowing that it's either a dictionary or a list. If it's a dictionary, you look up the key. If it's a list, you say which position it is, and then you get more dictionaries within dictionaries within dictionaries, and away you go. And so this code actually, when it runs, it prints out the screen name and then that status and the next person. So it's my first 5, in that case, my first 5 friends and their most recent status, the first 5 people. Now, let's talk a little bit about how this security works. And so you have to go to the website. You have to have a Twitter account. You can't talk to Twitter API without a Twitter account. And then you go to this website and then you set up a key. You say, I'm going to build an application that is going to consume the Twitter API. And then you go in, you have to work through, there's documentation on how all this stuff works. You set up an API key, you set the application. So I made a key called Python on my laptop. And it gives us some values. It gives us a consumer key, a consumer secret, a token key, and a token secret. And you get to regenerate these. And there's this file called hidden.py, and you edit them and copy and paste all the stuff from those pages, those 4 values, into these strings. Now, if you download my code, I don't have my keys in there. I got some placeholders for this stuff. So you got to get to this web page that's on Twitter, copy these things in, and then the TWURL code will start to work. It uses a technology called OAuth, which is a way to sign a URL in a way that proves that you have the key and the secret and the tokens, but and it can't be modified in the middle. So once you send this URL, they can check the key and the secret to make sure that you truly signed it without actually sending the key and the secret. It's actually kind of cool and fascinating, but we won't go into it in great detail here. And so if you look at the code in twurl.py, this is the code that does it. It actually pulls in an OAuth library. That hidden.py, that is that code that you've got. And it's got the consumer key, the consumer secrets. This is pulling that from hidden.py. This is a lot of stuff that's using this OAuth library. Don't worry too much about that. Eventually it produces a URL that looks like this. And what happens is this was the base URL you were told to use. Then you have count equals 2 and screen name equals Dr. Chuck. Those parts are your parameters to that web service call. And then all this OAuth stuff is produced by this OAuth code and the consumer key and the secret. What happens is the key gets sent, and the secret does not get sent, but they send the signature, which is based on the secret. And then what it does is it rechecks the signature on the far end. Signature is a long string. By regenerating the signature, because the secret's available to both you to generate the signature and to them to check the signature. So it's kind of like a hash, etc., etc. You don't have to worry about all this. These URLs get really long, and your values that you need are in, the name of the URL is in, and you call this routine. It's called augment. That takes a URL and then parameters and then augments it by adding all this OAuth stuff. And so that's why it's called augment, to augment the URL. And once you got this set up and hidden working, then you sort of just augment the URL and then hit it. Now, if you don't have the right keys or secrets, or you don't have an account on Twitter, then it's going to blow up. But if you get it set up, you will be able to talk to the Twitter API with this. So this whole web services section, we've done quite a bit of stuff, right? We've looked at how, instead of reading HTML or flat text, we are creating structured data according to contracts, whether it be XML or JSON. We can retrieve and parse that information in a deterministic way. We talked about schemas that define the contracts so that you know if the data you're getting is wrong, you can know who to blame because the schema gets violated. And we've played with APIs where you're talking to someone else who's defining what the rules are and how to read their documentation. And even if they have an API key or need signed URLs, showed a little bit about how to do that. We're doing some code, sample code, playing through with some sample code samples. And you can get this by downloading it. I've got this whole thing downloaded, and I've got all the files here. And these are the files we're going to play with today. Today what we're going to do is talk about the Twitter API, and the one thing we got to learn about the Twitter API is we have to authorize ourselves, and so we have to, make sure that we have a Twitter account, and then we get some keys. And so in this particular application, if you want to duplicate what I'm doing, you have to go to apps.twitter.com, click this Create New Application button, and then get some codes. Okay, and the codes show up as soon as you hit this button and then one more button, which I'm not going to do on screen. And so what happens is there are 4 codes that you've got to put in this file hidden.py. The consumer key, the consumer secret, the token key, and token secret. These are just messed up, so I'll show you how this works and blows up if first, and then I'll put my keys in here without showing you. But basically, this is a little file you got to edit, or these Twitter ones don't work. You'll see what happens. So the first one I'm going to do is do the simplest one of all, and that is I call this thing Twitter test, and it just is going to go ask for the user timeline, and we can take a look at this, and we're going to take the URL, and we're going to augment the URL. This is the base. We found this looking at the Twitter API documentation. We're going to pass a parameter of screen name Dr. Chuck and a count of 2, so this is just a Python dictionary. And augment comes from this little bit of code called TWURL. And this uses a bit of code called OAuth, which is built into Python as well. Right? Yeah, that's built into Python as well. And it augments the URL, and it takes the key, the secret, the token key, and does a thing and signs it, and then makes this big, long, ugly URL, which you will soon see, and does this. It's a signature of the URL. So we pass this data back and forth to Twitter with a signature, and then they recheck the signature, and it's a digital signature that knows that this URL came from a program that knows the key, secret, and token secret. And so this augment basically is something that I wrote. TWURL augment is something I wrote to make it easier to add all these OAuth parameters. And you feed this code by putting your data into hidden.py. Lots of people get this to work, so don't worry. It's kind of cool when you finally get it to work. So let's take a look at what it does. Just know that this makes an awesome URL that does all the security. And we'll see one of those URLs. So ignore the certificate errors. This has to do with the fact that we're using HTTPS, and Python doesn't have enough certificates put into it by default for a lot of reasons, but our quick and dirty way is to turn them off. Thank you, Python, for reducing security by teaching us so that this is the best way to do it. That's a grumpy moment on my part. So what we're going to do is we're going to do a URL open. This bit here is to shut off the security checking for the SSL certificate. And then we're going to read all the data, and then we're going to print it out. And we're also going to ask the connection, this URL. Remember I told you a long time ago that URL lib eats the headers, but you can get them back. And now we're going to ask to get a dictionary of the headers back. And so we'll print those out. Okay, so this is really kind of just testing the body and the headers and printing them out sort of in as raw a way we can do. So let's go run this. Now this is going to fail the first time we do it because we haven't put the hidden variables in there. So if I say Python 3 twtest.py, it's going to run and blow up, and it's going to give you this 401 authorization required. That's a good sign because that means that you haven't yet updated your values in hidden.py. And so this is that augmented URL, and you can see the consumer key and the consumer secret and the OAuth token and whatever. Okay, so these tokens are like wrong. These aren't. Oops, Control C. They aren't real. And then but you'll notice it doesn't the key and the secret and the token key, the token secret and the secret, and that's all actually encoded in this signature. It turns out that you need to have the key and the token, the secret and the token secret to generate the signature. And where is the signature? Oh, there's the signature. Right there's the signature. And so this signature combined with the nonce, that you can only do this signature has a time and it includes all kinds of things. So even if you type this in, well, you'll see these go by, and it's not really breaking my security too much when you see these afterwards. So don't get all excited when you say, Oh, you revealed your token and your key. Well, I can reveal my token and key, but I'm not going to reveal the secret. Okay, so this adds all this OAuth stuff, OAuth nonce, OAuth timestamp, and these timestamps and nonces are made it so that you can't replay my URL even if you see the exact URL. Once I hit it, then you can't hit it again, and so that's what the nonce does. So I'm going to close hidden.py here, and I'm going to update hidden.py in another window. Okay, so I just, in another window, I updated hidden.py. I'm not going to show you that, but now I'm going to run python twtest.py, so twrl is going to read hidden, and now these keys and secrets are my real ones that I haven't shown you. So this should work. Fingers crossed. Yay, it worked. Okay, so it worked. So I'm calling Twitter. Here's the URL. Now, don't worry. The token and the consumer key are not enough to break into my account, and neither is the signature because you can't replay this. In about 5 minutes, you can't replay this anymore, okay? So you can't generate the signature. I've done one. The signature includes the time and date, so you can't, trust me, go read up on OAuth, don't worry. I haven't really revealed anything. But, so the first thing we see is this. So we see, and we should put like the line of dashes here. This is the JSON. It ain't very pretty. It's not very pretty. Okay, and so that's the JSON from there to there. It's just what most APIs give us back. It's really dense JSON, right? And so this is a byte array. Remember how you have to do a .decode? I didn't do a .decode here. And so this is telling, and Python is telling us this is a byte array, which it's a raw set of bytes that came from the internet, which probably are UTF-8. And if I put a decode here, then it would decode. If I say .data.decode there, then it would be fine. But we don't care. This was just a dump. Do we get anything? And so then, here, let's do this. Print. I'll just make this code different. Ooh, put some equal signs here, a lot of equal signs, so we can easily see where the thing starts and stops. So we'll run that again. If you look at those URLs, so that was all of that stuff, and then this is the headers. And so the headers again are not pretty. You get the headers. It's a dictionary. You got cache control, no cache, comma. This is the string key value. You got to find your commas key value. But the one that's really interesting here is which one is it? X rate limit remaining, right there. X rate limit remaining. So that means that for this particular API, and this header tells me that I've got 898 calls left. And this is when I will get more calls. And yeah, so let's see, yeah. So watch. I'm going to do this again, and you will see that I can only do this 897 more times now. Run it. I can only do this 897. So I am being tracked at this point. I am being tracked by Twitter. Twitter knows that it's Dr. Chuck that's doing this, and Dr. Chuck has done 900, he's done 899, 897, and if I keep running this, eventually Twitter will tell me, you got to wait for a while. And that's because Twitter doesn't want me, under my Dr. Chuck account, pulling out like lots and lots of stuff out of Twitter and making my own website. Now, I do actually have my own Twitter website using some cool software, www.drchuck.com/Twitter. And this I have to run, and it rate limits and causes all kinds of, whatever. So, okay, so rate limit. So, I'll save that. So that's tweet. This is just to test it, okay? Because I want to do something interesting. So we're not parsing the JSON that comes back. We're not doing anything tricky with this. And away we go. So, let's take a look at some more code. I think I don't need this anymore. So now I am going to parse this. So most of this looks the same. I've got that same user timeline JSON. I'm going to ignore the SSL certificates. I'm going to write a loop. So I'm going to ask the Twitter, I'm going to print, I'm going to get a Twitter account and quit if it's a blank line or if I hit enter. I'm going to use the Twitter URL augment the same way. That's going to do all the signing using from hidden.py. I retrieve it, and I'm going to retrieve it ignoring the SSL errors, and then I'm going to decode it. This time I'm going to decode it so that I get a real Unicode string. And I'm going to print the first 250 characters of it. I'm going to grab the headers, and I'm going to print the remaining the rate limit. So this is sort of a very simple version of this same thing. It really is decoding the data and only printing the first 250 characters. So let's run that. Dr. Chuck, boom, and it's got 896. So that's just a little simpler version of that with a little less brutal debugging. Okay, so now let's do something even more fun. Let's go to twitter2.py and tear it apart. And so, so again, we're going to look at my friends list or someone else, anybody's friends list. We're going to ask for the friends and ask for the screen name, ask for the first 5 friends, and then look at their statuses, open it, decode it, get the headers, print the rate limit remaining. All this stuff is the same as in Twitter 1, but now we're going to parse the JavaScript. I'm not even putting this in a try and accept because, hey, I'm talking to Twitter. I'm going to guess that Twitter is going to give me the right stuff. You'll probably want to put a try and accept here. Then I'm going to do a debug print. I'm going to do a JSON pretty print. Let's make that be 2 so it looks a little better. And then, well, I'm going to run it, and then you're going to see how we have to parse this. And we're going to see that it's a list. So we're done with that. And now we're running twitter2.py. So I'm going to go to Dr. Chuck, and this is going to ask the question who Dr. Chuck's friends are. Okay, let's go to the top. So it hit this API, and it has the screen name Dr. Chuck count equals 5 and all this OAuth stuff. Again, this is not a security breach by showing you all of this because the signature, the secrets aren't there. Okay, so if we look at it, it's an outer object or dictionary, and then the outer has a users, which is a list. And then each user has some stuff in it. So this one's Stephanie Teasley. It's got her screen name. It's got some descriptions. Keep on going. It's got her status, her latest status. For my friend, her status. Her source, where she's at. I don't know, man, she's got a lot of stuff here. Okay, there we go. That was the first one. Okay, and then the next one that I'm following is live edu, etc. And so you'll see that this is an array. So that outer thing is an array of users. Now, JS here is a dictionary. So I can say for you in JS subusers, well, JS subusers is a list. So the first U is going to be this Stephanie Teasley U, and the second U is going to be live edu. So that's all it took to get through all that stuff and figure that out. And then I'm going to say, get me the screen name of my person. So let's go in here. So that's going to pull Stephanie Teasley, Steph Teasley out. Then I'm going to go find her status. Let's find her somewhere in here. Use of status subtext. Come on. Okay, there's substatus. Substatus is all this stuff. More. Right there. That's status. That's use substatus is that. And then use substatus subtext is this stuff. So it's going to extract this bit right here. Okay. And so use status text, and I print out the first 50 characters of the screen name status. And I do that for the first 5 because I told it I only wanted 5. And then, of course, I get to see the rate limit. So let's go down to the bottom. So all of this is the debug print of the JSON I got back. Here is the program starting to print. Here is the screen name of my first friend. And here's the first 50 characters of her most recent status. Here is the screen name of my, and these are in reverse order who I've been following. So I've been playing with this live coding stuff, so I'm following them. What? Key error status, that didn't work. Why not? Oh, that's because live coding TV somehow doesn't have a status. So most of these work, so now you'll get to see me fix something, and when you download it, it'll be fixed. And so it says key error status, so that means that I've got to do a thing that says if status not in you, print no status found. Continue. Since sometimes there's no statuses. Who would have thought? I did not know that. Yeah. So you. Okay, so let's run this again. Oh, did I get to see my remaining? Oh, actually, let me change the order of this. Let me put this down here. It'll be wrong from the slides, but it'll be prettier now. Let's put the headers after the dump of the data. Okay, so let's run it again. Did I save it? Yeah. Dr. Chuck, blah, whole bunch of stuff. So I got 13 remaining calls on this one. So it's not the same as the other one. I don't get to call this too many more times, so hopefully I'll get the debugging to work. Sort of. I got a bad space here. I go no, not status found, no status found, and I need to put 3 spaces there. No status found. I'll make an asterisk. So let's run it again. And see, I got 13 remaining. So it's important you write code that's aware of your remaining. That's why I make so obvious about that. Go retrieve all that. I got 12 remaining, but my code starts to look, oh, dang it, I now have another space here. Hang on, got to fix that. I need yet another space. Hopefully, I can make this as pretty as I want it to work. Oh, wait a sec. I didn't even do Dr. Chuck. I did that wrong. Typed my name wrong. Okay, so now it works. Oh, well. So now I have my most 5 recent friends are this Steph Teasley, LiveEdu Official, Live Coding TV, Nancy Gilby, and Greg E. Kruger. And so there are their statuses, and I tore all this JSON apart using twitter2.py. Of course, after fixing hidden.py, which I'm not going to show you because it actually contains my real consumer key and consumer secret. You're seeing the consumer key and the token key go by on each of these URLs, but what you're not seeing is these 2 things, which are the thing I'm protecting, so that it's not a problem. Okay, so I will send that up, but there you go. Welcome. I hope you found this useful. The code will be fixed when you take a look at it and download it here from samplecode.zip. Hello and welcome to Python Objects. I'm Charles Severance, and we're well on our way to getting through all this material in the Python. So this lecture is in a weird place. I even debated where to put it in the book. I don't really want to teach you how to write a lot of object-oriented programming, but we're going to start using objects, and I want to be able to use the terminology. And so as much as anything, this lecture is about terminology and understanding the words, things like methods and method signatures and variables and inheritance. And so think of this as a terminology lecture rather than a learn how to program or learn how to use this. It's not something you're going to figure out right away. And there'll come a time when you as a programmer really want to start using object-oriented programming. It's really a powerful and wonderful technique, but I think it's too early as a beginning programmer to really say, oh, let's write a bunch of objects. So just relax and enjoy and learn this material and think of it as sort of a theoretical thing rather than, a how to program thing. And so part of this is we're going to start reading data structures, and data on how to use all these libraries, etc. And we're going to see the word objects, right? And then we're going to start hearing them. And I want you to be able to read the Python documentation so that you understand what's going on. And so, the word objects should make sense to you, even though you're not going to write a lot of object-oriented programming. And so page upon page upon page, database stuff, which we're going to talk about soon, uses objects all over the place. And the beautiful soup uses objects. We've kind of been using them, and I've been waving my hands, and I use the word method without defining it. But now it's really time to define it and go to it. So I want to review from the very beginning what we think of as a program. So the classic program, my favorite little minimum program, is our little elevator floor converter, which converts from European elevator floors to United States elevator floors. And the key to this is that it's input, processing, and output. And this is a good way to model any program. And in that process, we've got variables, and we've got logic, we've got algorithms, we've got loops that we write, we've got all kinds of things. And we construct a series of steps to achieve some goal. In object-oriented, and frankly, you've been using object-oriented all along, the program has lots of objects, and we're sort of putting stuff into these objects, taking stuff out of one object and putting it into another object. And you've actually been doing this all along. As soon as you're looking at dictionaries and lists, you're doing objects. And so an object is quite a little thing. It's sort of its own little space inside of a program that contains code and data. And so we're working together. All these objects are now working together. It's a bit of self-contained code and data, and it is one way to take a very complex problem and make it easier by breaking it into separate things that can be engineered and developed separately. And so you've been using string objects, or maybe you'd use Beautiful Soup or something. These are powerful capabilities, and if you had to look at all of them, it's just, hey, here's a thing, use this object, it'll do these things for you, and there's lots of details inside of it. Just don't look at it, don't worry about it. And so there's boundaries, that things that you can use, things that you can look at, and things that really you don't bother looking at. You go read the documentation and use it, and away it goes. But then someone had to write that, and so they built an object. So what we're going to do is look a little bit under the covers of what it takes to build some of these objects. And so if we think of this program that originally just sort of did processing, we can think of it as having some kind of an input, right, coming into our program. And we have a string object, a dictionary object, maybe eventually some objects like a database object or an object that we eventually define. And you can think of as we're receiving data, it comes in an object, which is a string object, where we start putting the strings in dictionaries and do whatever. We pull out a list of them. And so you can think of data as moving between these objects. And like I say, even strings, in the first week, first lecture, first week, first everything, we were using objects, and we've been using them all along. And so you can think of every string and every dictionary as a little program all by itself that has a bit of code and a bit of data. And so a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the right, a white space from the right. And so it's like they're almost little programs that have inputs and outputs themselves, and we can make lots of them. And there's lots of cooperating objects that make up an application. And one of the nice things about the object-oriented pattern is that they form boundaries, and within the boundary, if you're inside the object, you can say, look, I'm going to build you a string object or a database object or a Beautiful Soup object, and I'm going to build this capability, and I'm going to give it to you in the form of an interface, and I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it, and the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just like inside the object, they don't have to worry about what you're doing with the object outside of it, when you're outside the object, you don't have to worry about what's going on inside of it. We, as the user of the object, we talk to its interface and we get things from it and give things to it and use functionality within that object, but we don't have to look inside of this. We can just say, oh, it's a nice little magical thing. We read the documentation, we read a web page, and it told us to do this, this, and this, and away you go. And so it is sort of this isolation boundary that works both for the programmer who's writing the object and the programmer who's using the object. And so it's a very nice pattern, and so you'll see how we're going to build code and we're going to group it together, and then we're going to be using it sort of as a big blob of stuff. So some definitions in this space, words that I want you to understand. When we're going to create one of these things, one of these objects, instances, that has some data in it and some code in it, we have to be able to define the shape of this object. What code will each object have in it, and what data will each object have in it? And that's called a class. The key to a class, and this little picture that I've got up here in all these slides, is a key. The class is a template. It's not the thing itself. So it's a cookie cutter. It knows a lot about how cookies are made. And if you have cookie dough and you hit the thing, then you make as many cookies as you want. And so this nice little cookie picture is a great, mental model of how it works. The class is the template, and then the object are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, we have two basic things that we put in the class, and there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really just a function, but it lives inside the class. And then fields or attributes are data items that are in the class. And so they're variables that are defined in the class. You can define variables outside the class that you use in your program, and you've been doing that all along. But if you're saying, I'm going to build this capability, and it's going to have data inside of it and code inside of it, the code is the method or message, and field or attribute. And there are just two different sets of terminology. Method is what I'll probably use. If you look in some object-oriented patterns like Smalltalk or Apple, they often will call these messages. So you can either access a method inside of a class or an object, or you can send a message to the object. The same is true for field and attribute. It's just a chunk of data that's in the object that you may or may not have the right to access. So, like I said, a class is a template. It defines the characteristics of the objects that we're going to use to make it. It is the cookie cutter. So, dog is sort of the exemplar. Lassie is a particular dog, and so dog has fur, and dog barks, and dogs do all these things, and so we know something about dogs, but it doesn't mean we have a dog, right? The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances, or objects, are once we say, oh, time to make a cookie from the template, time to get a dog, we know something about dogs. That's the creation of an object, and that we call them instances, instance of a class. So the class is it doesn't exist, but we say, make me a new object using this class as its template. Oh, and now make me another one. And so we can have many, many objects from one class. So just like many cookies from one cookie cutter. Method is a bit of code that lives inside of an object. It's like a function, but it's scoped to within the object or within the class. Okay, so that kind of gets us started on some of the terminology, and we'll come back and we'll take a look at how we write code that's object-oriented. Okay, so now that we've gotten through the definitions, let's work into some sample code. But hey, look at this. We've got ourselves a cookie cutter and some cookies. So remember that a class is a template. It's not the actual thing. An object is an instance of a class. So you have to take the class and do something to make the object. And actually you can see here's some other classes. There's clearly a sort of a snowflake class and a gingerbread man class. That's an object, object, object. Somewhere out here there is a snowflake class and a gingerbread class. But we got a snowman object and a snowman object and a snowman class. So class is the template